Okay, since my last video, I have made some progress on the metal game engine. I added lighting, so it's basically at the same point as the OpenGL one. And so I was thinking about how I'm going to separate the two video wise, and I'm kind of thinking I might just not separate them and just update what I have done in both with my update videos. So, but this one will not be that kind of video. Oh god, the train is so loud. Hopefully you can't hear that. Um, my window's open and there's a lot of construction outside, so I apologize. This won't be that video. Because I've only worked on the metal one, but I will work on the OpenGL one probably for the next video. Since they're now at kind of the same spot, I want to keep them kind of in parallel. We'll see what happens with that. I can't promise anything. And I'm about to go for a little coffee walk. And as far as the gym, I joined a new powerlifting gym. Gonna throw in some footage from that. Today I am benching. Last time I went to the gym, I also benched. Time before that, I benched. I'm just kidding. But I bench a lot because I'm trying to hit, well, 405, but I'm very far from that. I hit yesterday. I hit 242, so like 110 kilograms. I think I'm just the powerlifting gym. The weights are in kilograms, so I'm probably just gonna stick with kilograms. But I believe my goal would be, I don't know how many kilograms. Anyway, I'm rambling. Let's go for a coffee. Okay, so here I'm just walking to the local Vietnamese coffee shop. I don't know why I'm doing a voiceover now. I just didn't feel like typing. But maybe I'll keep doing this. It's probably a lot easier and faster. But nothing really to talk about with this footage, TBH. But look at that. I'm at my new gym, my new powerlifting gym. That guy was deadlifting like 500 pounds. I've never felt so weak in my life. But here, this is my bench day a couple days ago. I believe this was about 110 kilograms, so about 242 pounds. I am working on trying to be a lot stronger than the bench press by doing it more frequently. So I'm doing it like 3 times a week. This is quite heavy. You can see me shaking. But, we must struggle to grow. And then that was me deciding if I should do that weight again. I don't believe I did. Yeah. So I lowered the weight. Here, I'm just going for more technique and a little bit of hypertrophy. So I believe I was pausing and doing really slow on the way down. And then also my leg cramped up there. So that made this super fun. Yeah, I feel like in the next set I actually was able to do it a little bit slower like I intended. Yeah, this one, I watched the video of myself in the last one and I realized I was going kind of fast. So this one, I really tried to focus on going as slow as possible, pausing at the bottom. Yeah, very slow, very controlled. I believe this is 30 kilograms on each side, so plus 20 kilograms, 80 kilograms. Yeah. what is that in American weight? I don't know. Okay, back to coding. Sound. My favorite sound in the world. Oh, Lord. You know what time it is? Time to go to the gym and also talk about my game engine. I said air quotes. I gestured air quotes because I don't really consider this a game engine. More just a 3D renderer, but you know, the algorithm encourages lying, which I think is bullshit, but actually, no, I love lying. Lying's good. Do you guys know I can bench 500 pounds? No warm up. See, that was super fun. Okay, so like I said, I have wait one sec. Oh my god, I don't know how to use my computer. Okay. Damn, this chick got my lips itching. My ips itching. I bet I don't even. Okay, so like I said in the intro, I have pretty much gotten to the same point as I did in my OpenGL renderer. As you can see, we got a box. It is lit up. I could definitely improve the controls, I won't lie to you. But, you know, we're learning still. One thing that was noticeable to me, though, is the lighting looks quite a bit different on the OpenGL one. I'm not really sure why. I feel like the specular highlights are not as pronounced. That could be a number of things. It could be a bug in the OpenGL one. It could be a bug in this one. I don't know. I'm still learning. Trying to figure this stuff out. But I will just take you through what I was able to implement since the last video. So main thing, besides the lighting, of course, is that I actually did some organizing. So if you take a look over here, I have folders, and also before it was a Swift package. The idea behind it being a Swift package is that people could just download it, like something like Raylib, and use it like a game framework. Eventually, I figured that really isn't worth it because Xcode just doesn't handle metal very well in a Swift package. And then Swift packages in general are not fully baked, I would say. They're improving things, but some certain things that I wanted were just not available, like a bridging header, which is a little annoying because I wasn't able to create like structs that were available to Metal and Swift. So now that I do have that, though, I now have a bridging header just called common.h that holds all this stuff that is shared between Swift and Metal. Metal being my shaders. Yeah, and then things just weren't working as well. And I couldn't just like run an app. I had to use Swift UI previews or pull it into a project anyway to test things, which was a pain in the ass. I wasn't getting error messages. It was a whole lot of things that should work, you would think, but Apple just doesn't care about their products at times, I've noticed. So, developer products, that is. Their consumer products are pretty good, I guess. If you like that kind of stuff. If you like this capitalism, I'm not a big fan. So, but I don't know. But their developer tools, ass. Very bad. Apple, please do better. They have gotten better over the years. Xcode used to crash constantly. Now it crashes often, I would say. But not like every day. Like Xcode would crash for me every day back in the day. Now it's like every few days. Depending on what I'm working on, it actually crashes quite a bit working on this, which is super fun and not making me want to die at all. /S sarcasm. Anyway, let's see. So let's just go through some of the stuff I changed. So the main thing is I created structs to hold lights, similar to what I was doing in the OpenGL one. So all the same stuff. The only difference is instead of having the constant linear and quadratic portions of the attenuation, I just have a vector called attenuation. The reason is because constant is a reserved word in Metal, so I couldn't use that word. So we're just doing attenuation. So I don't remember if I explained the lights that well or at all in the previous one. So directional light is just a light coming from an infinite point. I do remember explaining that. It comes down at an angle, hits everything at a certain angle. So you just need the direction, and then you just need the ambient, diffuse, and specular components of that. And then for a point light, it is a point in your scene, and it shoots light all in every direction. So you just need the position. And then attenuation is just how that light decreases in strength as a function of distance from the light. And that basically is just a quadratic equation. That's why it has those three things. So if you take a look, this is very similar to the code in from learnopengl.com. It is actually exactly the same code, but translate it to the metal shading language from GLSL. But basically, all we do for a directional light, we normalize the direction of the light and invert it. We find the diffuse portion of it. Actually, just noticed something I can change. So we have this max function here. We find it whether it's the max of 0 or whatever is the return value of dot. You can actually just do saturate. Basically, it just keeps it from being negative, but what saturate does is it keeps them between 1 and 0, which is what we want. So basically the reason I'm using max here and down here I'm using saturate is because I accidentally deleted this code after I wrote it the first time, and I changed everything from max to saturate, but when I undeleted it, I forgot to change it. Anyway, let's make sure that still works though. It should. It do. So we find the diffuse portion of the light, and that is just the normal, which is the vector that points perpendicular to the surface, or the tangent of the surface. So like if it's a cube, it'll be pointing directly straight up from the cube. If it's a sphere, it'll be perpendicular to the tangent line of it. Basically, you need that to know what direction you're pointing out from the object. Next, we reflect the light along the normal. We do minus. We invert it again. And then do we invert it? Because it's already inverted. So yeah, I don't. Oh, wait, yeah. So light direction, we want to invert it from what's coming in. So like if it's pointing towards it, and then when we reflect it, we want to reflect it. Actually, let me look at the book real quick, because I don't know if that's correct. Let's see. Nope, that's correct. Okay, so we do actually want to reflect it based on the negated light direction. Okay. And then we get the specular component. So specular is shiny stuff. Diffuse is not shiny stuff. So we get the diffuse reflection, the specular reflection. And that is by taking the dot of the view direction. So that's the view of from the camera. And then we reflect it. We multiply it, or take the power of it to the material's shininess level, which is like 32. I have it hard coded for 32. I wonder if that could be why it's not as shiny. I wonder if I believe in common. No, wait. Shader depth? Yeah, shader depths, I did set this to 32. But I don't think this is... it probably is being used. But okay, so what if I set this in the fragment shader? So I'm creating the material in here. So if I go... I don't think that would make a difference, honestly. Yeah, it didn't really make a difference. I don't know. Like, it's very hard to see the reflection. In the OpenGL one, it's way, way shinier, I've noticed. You can see it a little bit, but it is very difficult to see. I think my calculations could be off in some way, but... I don't know. That is for future Maddie to figure out. But yeah, after we calculate that, we take the ambient light, multiply it by the texture. We sample the texture, and then just take the red, green, and blue components. The same thing for diffuse, except we multiply it by this diffuse reflection float we created. Do the same thing for specular, and then we just add all three together and return it. And that is being called up here calculate directional light. And point light is very similar. The only difference is we have the attenuation here, and we grab the distance of the light from the position of the fragment. So I had a bug here where the attenuation was much smaller than I expected. And the reason is I was actually sending in the, I was passing in the position in, that's already been transformed. So what we wanted to do is we go to the vertex shader. We have like the position to get the position relative to the camera. You have to multiply by the projection and view matrices and the model matrix, but what I needed was the position in relative to the actual world. So when you get the position first, it's relative to the object. You multiply by the model matrix to convert it to world space, and then view to change it to space based on the camera or view space, and then the projection is to change it to either a perspective where things farther away are smaller, or orthogonal, which is everything is the same size. That's what the projection matrix does. So we take this and just multiply it only by the model matrix and save that as world position. And that's the actual distance you need when you're doing the attenuation. And then there's just an inverse quadratic equation. So a plus b times distance plus c times distance squared. That gets the attenuation. We do the same stuff as the directional light, and then we multiply each one by the attenuation. So the farther away, the weaker the light will be. And then we multiply them together and return them, and we do that in a loop for each light. Yeah, so basically I'm doing this when we pass in the diffuse and specular texture. If we only pass in a diffuse texture, we won't calculate the specular one, and just pass in the texture, and otherwise we will just pass red. And then I also have a second fragment function for if I want it to be a solid color for debugging purposes. Yeah, so I have this cube this cube model, and I'm manually creating the vertices with the normals and the texture coordinates here. This is also in clockwise winding order, or counterclockwise winding order, so we can use that to cull faces that are not being shown by the what's it called? That are not being seen by the user. So for example, so if I go to the renderer, I'm gonna change this to wireframe mode. So if we run it, take a look. If it works. Why is it not showing? Oh, what? That's all. Alright, let's run it one more time. Okay, there we go. So notice the wireframes. They're here. Oh, baby, quit unexpectedly. Okay. All right, so notice how these wireframes, there isn't much being rendered. If I go in here and I comment out set front facing and cull mode back, and we run it, notice there's way more vertices. And the reason for that is because it is rendering the squares that would not be shown based on where we are in the scene, based on our view. So we don't want to render that stuff that's not going to be seen anyway. So that's what this does here. So running again. And we no longer see those extra vertices. Cool stuff. Wow. And that's not noticeable when the wireframes are not set to be true, but you can trust me. Well, yeah, actually you can be shown, because we go inside the box, notice there's nothing inside of it. It doesn't show anything. But if I go here comment that junk out. And we go inside the box. Ooh, there's the inside of the box. But we don't really need to render this because in the future there will be collision. You won't be able to just walk through a box. Okay. I can't remember if there's anything else new that I wanted to show. I think that's about it. As far as like things I've changed. I don't know if I had the game scene stuff here before. I think I did. Yeah, I had refactored before the last video. But basically what's going on here, I'm just like, when I call render, I'm creating all those lights. It's probably a better place to create them, so we're not creating them every frame. But having some issues with ownership from the struct. So I just found it easier to just create them and then pass them to the encoder, to the render encoder. If there's a better way, please leave a comment, tell me that I'm stupid. Okay. Yeah, from here, the plan right now is I have this struct for a plane, which would just be a flat surface. That's going to be the floor. I have it commented out right now because I'm having issues with the vertex data that's being sent. It's causing my game to crash. I don't really know why, so I'm just gonna figure that out off video. But hopefully I will have that done soon. Next goal is to get actual 3D models in both this renderer and the OpenGL one. After that, I don't know, just keep adding features. Probably next video, like I said in the intro, will be both, going over both, which hope you guys like long videos, because I'm gonna be yapping. I'll be honest with you. All right, I think that's all I got. Thank you for watching. I'm gonna go to the gym. I forgot to record my workout that day, but I tied my PR, 120 kilograms, aka 264 pounds. And then I also attempted about 275 pounds or 120 kilograms. Ignore my mustache. I just woke up. And my hair. Don't ignore my new glasses though. But yeah, I attempted 275, failed spectacularly, but it's okay to fail. You must fail to get better. Anyway, thank you for watching. I hopefully will be back with a new video updating the OpenGL one in less than a week, hopefully. And also the metal one. Hopefully I get that floor thing figured out. Anyway, thank you for watching. Go for a walk. Bye.